So for a moment, close your eyes and listen to this. So, without even opening your eyes, you could very easily tell the difference between my voice and the sound of this guitar. So that is something very interesting, actually. So if you listen carefully, the frequency of this note and the frequency of my voice were almost same. The amplitude of my voice and this note was also the same. Okay, they were almost, so they had the same loudness and they had the same pitch. So what was different between the two, between the sound of the guitar and my voice? And obviously you could very easily tell the difference between my voice and the guitar, or even if I played a flute at the same note and the same loudness, or for that matter even a piano or any other instrument, you could very easily differentiate between the sounds of various instruments and my voice. And in fact the voice of different singers you can very easily identify, right? So if two singers have sung the same song, so they have the same loudness and the same pitch or frequency, yet you can find the difference between the two voices. The voice of singer A is very different from singer B, and that is something very interesting, right? So this is associated with the last characteristic of sound, which is timbre. So timbre is what enables you to identify various sounds of different musical instruments and different people, different singers, and yeah, different sounds that have the same loudness and the same pitch. So the reason that you could differentiate my voice from the guitar's sound, was because of the different timbre of my voice and the guitar's sound. And similarly, my voice and let's say Arijit Singh's voice, the two voices have very different timbre, and that is why if I sing a song and if he sings a song, you can very easily differentiate between the two voices. And same applies to other singers. Okay, yeah. So that is what timbre is. And if you wish to know understand how timbre actually works, um, at a deeper level, because timbre is just a word after all, right? How does it actually work? After all, it's just compressions, rarefactions, air, right? So how does that make any difference? How does the timbre make any difference? Well, the answer to that question is simply that timbre is actually, so my voice is not a pure note. Even this is not a very pure note. What is a pure note? So if I said, let's say, that is a note. I told you that this was around 80 hertz, I believe 83 hertz, close to that. So, but this is not exactly 83 hertz. So this guitar string, and you might have noticed that in the slow motion video of the guitar also, that the vibrations were not simply these vibrations. There were all sorts of weird vibrations. So actually this one note is not only made up of 83 hertz frequency, but it has many other frequencies mixed with it. Obviously 83 is the most prominent frequency, and that is why we call this 83 hertz, but it has other frequencies in it, and that is something that you'll understand and study more in higher classes. But yeah, that is, so the composition of the various frequencies that this note has is what constitutes its timbre. So yeah, I might also produce sound at 83 hertz, but the composition of the other frequencies that my sound has is different from the sound that the composition of the frequencies that this guitar has. And that can be seen in the shape of the graph of the sound. Yeah, at this level, all you need to know at this level is that timbre is the quality of the sound, and it enables you to differentiate between the sound of a guitar and the sound of a human being and the sound of various singers. So that's it for this video, and I hope you've understood the meaning of timbre. Bye.